Let's discuss auto and automatic type deduction. So in C++ 98 and C++03, declarations of variables always needed to include the type of that variable, right? C++ is a strongly typed language, so you have to include the type with every variable that you introduce. So in C++11, this isn't true anymore. You can use the auto keyword to instruct the compiler to deduce the type of a variable based on its initializer. So if you declare a variable on its own, if you don't initialize it, then you cannot use auto because the compiler doesn't know what you're talking about. It can't just introduce arbitrary variables later on. So if you do have an initializer, then the compiler knows what type that initializer is because the compiler is reasonably intelligent. So in this example here, you can see I have an int up top and I'm initializing it to 0. So the compiler knows 0 is an int, so I can use auto here and the compiler will replace that with int internally. And similarly for the float that we have, the compiler knows that 1.0f means a float, so it will replace auto with the float. So auto is really most useful when you're working with very long type names, okay? So you can see here in this example, I have a std vector of std pairs of 2 floats. And that's a very long type name, okay? If I want to declare a variable, okay, if I want to, for instance, walk this container, the standard C++ 98 and 03 way was to declare this variable by naming the type, naming the name of the variable, and then initializing it to whatever here. In C++ 11, the compiler knows that vector.begin returns a type of that vector's iterator. So I can replace that entire long type name with the auto keyword, and the compiler will replace that with the iterator's type for us. So you also have Decltype, which stands for declared type. So previously, there was no easy way to have return types of a function depend on template arguments. I mean, you could have return type be a template argument, but types that are related to operations involving those template arguments, it wasn't always easy. You could do it if you had a type traits class or something along those lines, but it wasn't easy. So in C++11, you have Decltype. So you can see here we have some example code called mult, which takes 2 template arguments of the same type and returns those 2 things multiplied together. So for most classes and most primitive types, this actually works fine. For instance, ints, an int times an int, or int star int, will always return an int. Okay, so this code will compile and work just fine. But, for instance, if you're working with a matrix multiplication library, okay, your return type of a multiply might not be equal to the return types of both arguments. So, for instance, you could have a function like this. Okay, so this does more or less the same thing. It returns the multiplication of both those elements. Okay, but the return type is dependent on the type of the star operator, okay, involving both of those types. So this is completely valid as long as there is an operator star with type t on both sides, and it will return the correct type, and it doesn't necessarily have to be equal to the template type.